So with these two equations, we can either find out the acceleration or the mass, or we can find out the total sum of the forces depending on what we know. If we know the sum of the forces and a few of the other forces, we can eliminate them and find the one that's missing. And this will make more sense when we do a practice one in a minute. The other formula that we have for this chapter is for the force of friction. And the force of friction is the normal force multiplied by mu. Mu is also called the coefficient of friction. And it is a ratio between the normal force and the frictional force. And if we rearranged this to just solve for mu, we would see the force of friction divided by the normal force to equal mu. So we can see that if we had newtons divided by newtons, the units would cancel out. So our mu has no units, and it's usually a number less than 1. And it deals with the two surfaces touching each other and creating friction between them. So if we know the normal force and the mu of something, we can determine the force of friction on an object, or by the same token, if we know the frictional force, we can divide by mu to find the normal force. And we can always determine the normal force on something if we know the force of gravity, because the normal force is going to be equal and opposite, the same magnitude as the force of gravity. So those are all the formulas that we're going to need to know, and so then we will work through a problem to see how we can apply using these formulas. Okay, so I'm just going to rewrite our formulas up here. We have our sum, so when we're looking at all the forces acting on an object times a certain acceleration. We have our force of gravity, that equals mass times the acceleration of gravity. We know the acceleration of gravity is 9.81 meters per second squared. And we know that the force of friction is equal to the mu times the normal force. And we also know that the sum of the forces is the force of gravity plus the normal force plus the applied force, plus the frictional force. So those are the formulas that were used to solve things. And we'll look at a problem from the Newton's second law problem worksheet that I gave you. And maybe we'll look at number 2. So number 2 says, during a football workout, 2 linemen are pushing their coach on a sled. The combined mass of the sled and the coach is 300 kilograms. The coefficient of friction between the sled and the grass is 0.8. The sled accelerates at a rate of 0.580 meters per second squared. Determine the force applied by the sled. So there's a lot of words going on there and a lot of numbers. So you want to break it down slowly. First thing you want to do whenever you're dealing with a Newton's law problem is you want to draw your object. So we're going to draw our square and we're going to identify the forces that are acting on it. So we know that we're going to have the force of gravity acting on the sled. We know that we're going to have the normal force acting on the sled. We're told that we have 2 linemen applying a force, and we know that the force of friction is going to work against them applying the force. So let's look at the numbers that we were given. We're given that the mass of the sled and the coach is 300 kilograms. So we know that's a mass. And we know that by using a mass, we can find the force of gravity using our equation up here. So we can use our FMA for gravity, and we can say 300 kilograms times the force of gravity times the acceleration of gravity, not the force of gravity. Force of gravity equals mass times the acceleration of gravity, and that's going to give us a force of gravity of 2940 newtons. So we know that that's going to be here, going downwards on our coach and sled. Now we also know that this is not floating off in the sky and it's not plunging through the crust of the earth, so the normal force is going to be equal and opposite of that. So we've drawn the arrow so we don't have to put a negative sign. Remember, it is just going to tell us direction at this point. So we know that those two values. So what else were we given? We were also given that the coefficient of friction between the coach and the sled is 0.8 with no units because that is our mu. And we're also given that it is accelerating at a rate of 0.58 meters per second squared. We notice that this acceleration is not 9.81 meters per second squared, so this acceleration has to do with our sum of the forces formula. And so we can use that to determine the sum of all the forces. Because we don't know the force of friction yet and we don't know the applied force, we're going to have to do some calculations to find those numbers. So we can do a couple different steps. We can say, let's find the sum of the forces using our general Fermat equation. We know our mass is 300 kilograms. And we know that it's accelerating at 0.58 meters per second squared. And so we know that using those two numbers, we get the sum of all the forces adding together to be 174 newtons. So when we add all those together. But we can't really use that yet until we figure out one of these other forces, the applied or the frictional force. Fortunately, we have another formula that tells us how to find the frictional force. So we can say the frictional force is the mu times the normal force. We determined that the normal force is equal and opposite of gravity, so we know that's 2940 newtons. And we know the mu is 0.8 with no units. So that will give us our frictional force. So our frictional force is 2352. And we can put that over here, 2352 newtons. Okay, so now we can say that we don't know what the applied force is, but if we were to sum up everything over here, the sum of our forces would equal all those forces added together. And so we know that gravity and the normal force will cancel each other out, so the sum of those two is 0. And we would know that so the only two left that we can sum up to equal our sum of forces is going to be the force of friction and the applied force. So we can substitute in our numbers for the force. The sum of the forces we know is going to sum up to be 174, and we know that the force of friction was 2352, and we're looking for the applied force. So once we move that over, we find that it is, and if we say that the sum of the forces is that, so we add this to that and we get something. We did forget to put in that our frictional force is opposite our applied force, so this is going to be a negative number here, so they're opposite each other, and so then we're going to add this to both sides and we're going to end up with 2530 newtons applied, and that makes sense because we know that they are actually moving the coach and the sled across the field. So we were able to determine all of the forces acting on it, the acceleration of the object overall, and the mass of the object. A couple of key words to look for when you're looking at Newton's law problems is if you have something that's moving at a constant speed or a constant velocity, we know that the initial velocity and the final velocity are going to be the same. So when we do our final minus initial velocity, to find the change in velocity, we're going to find that if they're the same numbers, that's going to equal 0 meters per second. And we know that the acceleration is equal to the change in velocity over time. So if our change in velocity over time is 0, our acceleration is going to be 0. So anytime we see something that has a constant velocity, we're going to know that it has no acceleration. Now this doesn't tell us whether an object is moving or not moving, it just tells us that it's not speeding up or slowing down. So it'll have the force of gravity acting on it, it will have the normal force acting on it, and it may or may not have a sideward force. So if you have something like this that says 10 newtons down, 10 newtons, the normal force, there may not be another force going from side to side. So this thing may be still, so if it's sitting, it has a constant velocity of 0, or it could have balanced forces this way. If an applied force is going that way and the frictional force is equal and opposite, that also has a constant velocity. And so all the forces are balanced. But it also may be moving in a constant velocity in one direction or another, but we just don't know that if it has a constant velocity. The other thing you want to look at are balanced versus unbalanced forces. If all the forces are balanced, that means that the normal force will cancel out the gravitational force. It's going to be the same, equal, and opposite of gravity. And the frictional force and the applied force are going to be equal and opposite. So the sum of the forces will then be 0. If you have unbalanced forces, that means the sum of the forces will not be 0. Okay, one of these is greater than another. So if the force applied is greater than the force of friction, then it will have an acceleration in the direction of the force applied. Or in the case of an object doing air resistance or whatever, the air resistance may be greater or less than the force of gravity if it's not the normal force. The force of air resistance, when a parachutist opens his parachute, it pulls him up. The air resistance is much stronger than the force of gravity at that point, but then the force of gravity overcomes that. So just some keywords to look at. The other thing you want to look at, of course, are your units. So if you have a number with kilograms, you know that that's mass. If you have a number with grams, you know you want to convert it to kilograms, and that's mass. If you have a number meters per second, that's velocity. And if you have 1 meters per second squared, that's acceleration. And if you have kilograms times meters per second squared, that's also newtons, which is force. If you have a number with no units, it'll be the coefficient of friction, or your mu. So keep your units in mind, and that will help you make sure that you're doing the math correctly. So we talked about some air resistance, so we can do one of those practice problems that talks about the skydiver and the parachute, so you can get an example of that. So again, on that same worksheet, that Newton's second law, we'll look at number 8. It says a falling skydiver is accelerating in the downward direction at 3.29 meters per second squared. The mass of the skydiver, including his parachute, is 67.2 kilograms. Determine the air-resistant force on the skydiver and parachute. So the first thing we're going to do, we're going to draw our object, and we're going to identify the forces acting on him. He's jumping out of a plane, so obviously gravity is going to be working on him. And we're going to have a parachute, and so we are going to have the force of air resistance working opposite of gravity. These are not going to be equal and opposite because it's not the normal force. He's not standing on the earth experiencing that force of gravity. So we're not going to be using those normal forces equal and opposite. So what else do we know? We know that his mass was given as 67.2 kilograms. And we know that he is accelerating at 3.29 meters per second squared. That's pretty much all we are given. So what can we figure out with this? Well, we look at this and we see that this is not 9.81 meters per second squared, so we know that this is going to have something to do with when we sum our forces. We want to figure out the force of gravity, and fortunately we do know that that equals mass times the acceleration of gravity at this point. That's not going to be the total acceleration on the object, but we can figure out that 67.2 kilograms times 9.81 meters per second squared is going to equal the force of gravity. And that number is going to be 658.6 newtons. We know that there's no forces that we're going to count moving side to side, so we don't have to worry about an applied force or a frictional force. But we need to figure out the force of the air resistance, and we don't have a formula for that. We don't know how else to calculate that, but we do have a mass and an acceleration, and we can figure out the sum of all the forces acting on him by using that. So we can say that his mass times the acceleration that deals with all the forces acting on him is going to give us the sum of the forces. And so the sum of the forces on him is going to be that number, 67.2 times 3.29. And so that is going to be 221.1 newtons. So that is the net force acting on him. So if I added the force of gravity and the force of air resistance, that would equal that. So now I can use my sum of the forces to find out what air resistance is, because the sum of the forces tell me that when I add them all together, that will be that. So sum of the forces minus the force of gravity will give me the force of air resistance. And so I can say that my sum of the forces was 221.1 newtons, subtracting 658.6 newtons is going to give me the air resistance. So that's going to be negative 437 newtons. Now remember that negative just tells me a direction. So my units on my force of gravity were positive, so this is negative 437 newtons. It just means it's acting in the opposite direction, so we already knew that. And so our air resistance on this skydiver is 437 newtons. So I hope that was helpful. See you in class.